right, so how'd that go? Like you know it? Okay, remember, unlike a normal Algebra 2 class, where they literally, I had a girl who's in Algebra 2 right now, and she wants to go to Math Team Pre-Cal next year. So she came in here just to watch my class, and just last week, to see how fast it was moving. And I asked her, I said, how many times do y'all take the unit circle quiz? She goes, until everybody makes 100 on it. And I said, how long does that take? She goes, at least a week. Because they do stuff in a different order than us, so they've already done some trig. And but most of mine do really well the very first time. I mean, maybe a careless error here or there, maybe a 7 pi over 4 instead of a 5 pi over 4 in the wrong spot. But then that's the end of it. It's like they don't even use it. Like they can't even tell you why they're doing it. They're just doing it for the sake of doing it. So what I want to make sure you understand is why we're using it. It's a tool, right? It's like I can use my shoe to beat a nail into something. It's just not going to be really effective. It's going to take me a while, depending on how hard my shoe sole is. But I would much rather have the right tool. So knowing how to use it effectively, right? So knowing how to use that unit circle is what's going to separate you, hopefully, from the pack, and being able to use it in a way. I don't mean use it like I'm going to have to carry it around, but having like a visual hammer in your head, having that thing burned into your brain. So, so when you're thinking, all right, how do I find the tangent at 120? I think y'all are pretty good about visualizing that 120 would be, that's 0, that's 90, 120 would be just right there, right? And what does it take to get there? A little, a lot, but left, up. So negative a half squared root 3 over 2. And if you can just get the coordinate, then you're home free. Well, you're home free if you know that your trig functions are defined and know the right x, y, and r to use, or in this case, just the right x and y or reciprocal of x and y, and you'll be in pretty good shape. So knowing that, being able to get that coordinate, and then boom, you can attack the problem. Then you don't, now you're not handcuffed to having this unit circle around. I mean, I had a kid years ago in regular pre-cal, and every time I even said something about trig, you'd see his hand go up. It was really funny. The class started laughing by the end of it. His hand would go up. Can we get a copy of the unit circle? I mean, like, it was like he was chained to this thing. He couldn't think outside of holding it. It's like like Linus in his blanket. So I don't want you to be like that. Maybe initially, I understand, but I want you to get to the point where at the very minimum, even though you might be able to go, oh, tangent of 120 is negative root 3. You might not be that quick, but you need to get to the point where you can go, okay, tangent of 120, negative 1/2 square root 3 over 2. The y is root 3 over 2. The x is negative 1/2. Put one over the other and simplify. If you can do that, you're going to be in great shape moving forward in this class, in pre-cal, and also in calculus. And it is a big deal. A lot of my calculus kids, they don't know the unit circle. It's like they've forgotten it. To me, they don't really get what's happening on it. They just memorized it and dumped it. So hopefully that's not you. Okay, today, before we get into this, I want to make sure you can use a calculator. Does anybody not have a calculator?
Oh, I just grabbed this one. I don't know.
Perfect. Okay, you've made me a happy person. Does anybody have an Inspire? Raise them high. Okay, you're going to be very happy. Go home and hug your parents because it's going to be easier on you than the rest of you. Does anybody who does not have an Inspire think they'll have an Inspire by test day? Okay, if you have your siblings, guys, if you plan on taking this class next year, they teach from Inspires. I say they. I teach from Inspires. And if you're going to stay in this class all the way through calculus you can go either way with the TI-84 and Inspire. But you're going to have a graphing calculator. You might as well go get one. If you have an Amazon membership, it'll be at your doorstep on Wednesday. I'm going to show you the difference. It is much easier to use an Inspire to do the work we're heading towards than without. And it's because these little dinky calculators, when you look down, you see the trig function sine, cosine, and tangent. And then above them, you see sine to the -1, which is not cosecant. That's inverse cosine. Okay, that's different. So it doesn't even have the cotangent and the secant and the cosecant application on there, which means if you don't have that, what you're going to have to do is convert. Each and every time you're going to have to convert to be able to do the work. So if I were you, listen, I'm a parent 3 times. I had to buy 3 of these suckers. They're not cheap. They're like 150 bucks for maybe, what's the current going rate on Amazon? I honestly kind of hate supporting the evil empire, but it is the cheapest most of the time. Let's check it out. Amazon, TI Inspire CX2. Don't do that. Don't ever get the sponsored stuff. Okay, there's $132.50 with tax. In Homewood, you're probably looking at close to $150. So right there, do not buy whatever you do. This is the TI Inspire CX2. You do not want the CI Inspire CX CAS. No CAS. Not only are they more expensive, like this one, they're more expensive, but they have what they call a computer algebra system, which is truly wonderful. But it is illegal on the ACT, the SAT, and all those other testing. AP tests, it's illegal. So, I mean, I'm not telling you that every person who administers those tests is going to walk around and look at your calculator. Sometimes they're an English teacher who does just know the difference, but you don't want to have that. I have a kid who bought one in my junior class, and he's going to have to borrow somebody's CX2. But do not buy the one that says CAS on it, okay? Unless you just want to have two calculators, whatever. But you want this one with tax, it'll be about $150 free. It'll be at your door in a couple of days, and then you can start getting used to it. You're going to need one anyway. You might as well go ahead and get it. Again, sorry to be the bearer of bad news. I have had kids that have made it through my class, calculus, without ever buying a graphing calculator. But they can't do any of their homework at home. They got to come in here, borrow one of mine. Technically, I'm not even allowed to let you borrow one. I do, but I'm not supposed to in this pandemic we're in. So really talk to your parents, see about that. If you have a financial situation that's completely, you need to talk to me personally. I have a couple floating around here that I can let you borrow, like on a test day, or if you want to do homework, but I can't let them leave the room. You with me? Okay, so I'm going to show you the two ways we're going to go about doing stuff. Now, initially, I just want to throw some problems up here and see if you know how to use your calculator. So this is not going to be any of this stuff right now. So I'm going to zoom in. Everybody tell me, or use your calculator to find the tangent of 43 degrees. And make sure that you read that question on the test or whatever about how to round. Because sometimes I say round to 2 decimals, some to 3, some to 5, whatever. I never said 5. 2 or 3, 1. What did y'all get when you did this?
0.93.
0.9325. Did anybody get something different? Be honest. Did anybody get anything different? If you got something different, you're probably in the wrong mode. Okay, try cosine of 223. Negative 0.7314. Can anybody tell me what that means? What is that? It's a ratio. You said that on day one. Good. All trig function of angles are ratios. So what that means is, at 43 degrees, if you were to have a triangle that had a 43-degree angle, what over what gives me that? Y over x, or opposite over adjacent, right? That's tangent. So right there, what do you know about, if it's pretty close to 1, then you know that your opposite and your adjacent is what?
Like,
pretty close to each other, and that your angle is pretty close to 45 if the opposite and adjacent are pretty close to 1, and sure enough, that's the case. Right here, what do you know about this? Now, this is funny because there are no triangles with 223-degree angles, are there? So when I look at that ratio, what that really represents, it's a ratio, but it's 223 is what, 180 with an extra 43 on it? Is that something like 223 right there? So what it really is saying is the ratio between the two sides of the triangle made by this thing's reference angle. Remember we talked about reference angles? So it would be this triangle. We never make the triangle to the y. It's always to the x. So on this triangle, the ratio of the adjacent and that is about 0.7. Why is it negative? What do you know about your x movement here? I went left, so that's why it's negative. Y'all seeing that? Okay. So try this now. What if I said, what is the cotangent of 110 degrees? Oh, man. Well, if you have an Inspire, have y'all figured out where the trig stuff is on the Inspire? Where it says trig, right? You're smiling right now because you have cotangent. So you can hit the trig button, grab cotangent, type in the 110, and what does it spit out? Negative 0.364 of your parents. And everybody's happy. And the rest of y'all are like, crap, I got this crappy scientific calculator. And that's okay, because you learned that what was the relationship between cotangent and tangent? They're reciprocals. So one thing you could do is just do the tangent of this and flip it, right? So that's literally what I'm doing, but I'm going to show the math. Like, I know this rule. I know that tangent of an angle is y over x. I know that cotangent of an angle is x over y. We know this, right? Well, what that means is that the tangent of the angle is the same thing as 1 over the cotangent of the angle. You get that? So if I want to find the cotangent of an angle, that's the same thing as 1 over the tangent of the angle. Now, I'm rarely doing that. It's true, but I rarely am trying to solve for tangent by using cotangent. Why? Because I have a tangent button. I would just type it in my calculator like I did over here on the first one. But in this case, I can't do that. So what you're going to have to do, unless you get an Inspire, even the 84s don't have this in there, although they might have an access button that links it to some program. So I'm going to have to say, well, that's the same thing as 1 over the tangent of 110. So basically, I'm finding the tangent of 110, and I'm writing that decimal right there, and then 1 over that decimal is going to spit out. Now, guess what the biggest mistake I see on this? Do what? That is a mistake. The biggest mistake is this. Check it out. People go, oh, cotangent of an angle is the tangent of the reciprocal. And they do that. But that's not true. You're never, log this away. You will never, ever, ever take an angle and take a reciprocal of an angle in any trig that I've ever heard of. Now, you might take a reciprocal of a trig function of an angle, but you will never flip an angle. So if you have a radian measure like 7 pi over 3, you are never going to flip it into 3 over 7 pi. If you have a degree measure like 45 degrees, you're never going to make it 1 over 45. Now, you might make the tangent, a cotangent of that, 1 over tangent of that, but you're never going to flip the angle. So if you ever find yourself doing that, go, okay, wait a minute, something's wrong here. Now, does everybody with a regular scientific calculator, are y'all all able to get this? Okay, great. What if I give you secant of 312? Secant, what do you think you're going to have to do? Tell me.
You find the sine of it.
Is sine the reciprocal?
Or the
cosine, right? So you're going to take 1 over the cosine of 312. Or take the cosine of 312, then flip it. Because when I take the cosine of 312, that gives me a ratio, right? I can flip a ratio. I just can't flip an angle. Does that make sense? And what does that give me?
Negative, or no, 1.49.
1.4945?
Yes.
And then lastly, what about cosecant of 103? What are you going to do there? 1 over the sine of 103. Again, don't take the reciprocal of the angle. Take the reciprocal of the trig function of the angle. And what does that spit out?
1.0263.
1.0263 if you're going to 4 decimals. Not too bad? Okay, so if you've got that part down, great. You know, believe it or not, This is one of the more missed things on my test. At the very beginning of the test, I give some simple things like plug in your calculator. People miss it. They're in the wrong mode. They don't have an inspire, so they keep take the reciprocal or whatever. They take the reciprocal, the angle, and it becomes a mess. Just be careful about this. We're not going to be doing a lot of this moving forward. We're going to be doing other things with trig, but be careful on this kind of stuff. All right, and then lastly, what would you do if I said this? Anybody? I got that rounded to 3 decimals. Am I right or wrong?
What was it?
Anybody get
I did
0.039?
Yeah, I got that.
Guess what mode you're in?
What mode?
You're in degrees.
Uh-oh.
Do you see a bubble for degree? Now, normally the pi is a big hint, but pi is not a unit, guys. Pi is a number. I could say that I have pi degrees. I don't because it's confusing to you guys initially, but I could. Pi degrees would be 3.14-ish degrees. I don't know, again, why I would do that. It's just kind of mean. But if you don't see a bubble to represent degree like you do, then you assume it's a radian. Now, I could be really dirty on this test and say, hey, find tangent of 135. Now, most of you are thinking that, oh, that's 135 degrees. That's on the unit circle, right? You pull out your unit circle and you get -1. That would be really dirty of me if I did that because that technically is 135 radians. If it doesn't have a bubble, you assume it's radian. Now, I'm not going to do that. But right here, you have to assume this is a radian, which means you need to change your mode. Does everybody know how to change the mode?
Do we change it to radian?
Okay, does everybody know how to do it on their little cheat calculator? You do not?
DRG.
Somebody who helps somebody, and if we still can't, and then who has an inspire? Do you know how to change it? Okay, here's how you do it with an inspire.
Which one do you change it to?
Radian. So hey, real quickly, here we go. Here's the inspire for those of you that have inspires. And for those of you that have a sneaky suspicion, guys, lock in with me. For those of you who think you'll have an inspire by the end of the week, then check this out. So if you're on your regular page and you're working off calculate, which is A. So let's just say you're doing calculations right here. Y'all with me? Which is probably where you've been a second ago. You're doing calculations right here. Then I'm in radian mode. You can see it in the top right corner. Okay, if it says degree, you're probably in degree mode. The way you change it is you just grab the trackpad, just kind of rub it, make it your friend, and bring it over here. And you probably don't have a degree, a gear there. This is an older Inspire. But just go up there and click on the battery, and this little thing will pop up. Oh, that's right. They do this. If you have a newer one with the white face on it, and you just click it, it'll change it from degree to radian. If you have an older one, you have one like mine, so you have to click the gear. This pops up. Go to dock settings, go down, and click on that button and change it to radian. And then just hit enter twice, and it'll be in radian mode. Yes, it means it's now in radian mode and it's not doing anything. So now if I say, what's the secant of 312, and you type it in there, it's going to think it's 312 radians. Now let me show you another thing you guys can do, which might be better for you in this class, since we normally operate off degrees. It might be better, and this is definitely something we can revisit when a bunch of you guys get them in here, is leave it on degrees. Okay, just leave it there. Let me show you this little trick. And now, if I want to do, what did I say, tangent of 5 pi over 7?
Yeah.
Watch, tangent, fraction button, 5 pi over 7. Watch this. Go just outside the fraction. Right now I'm on the bottom of the fraction. I'm going to go to the right, and I'm going to be blinking right there. Okay? This is a great your calculator thinks it's degrees. So what you can do is if you click the pi button, it's got that little R right there. Like, see degrees, radians, gradients? Click the R, and you're saying, hey, this is a radian value. You're telling your calculator to overrule degrees for this one problem, and it will spit out the radian value. Y'all see that? So for those few of you with Inspires, that might be a better idea because most of the work we do, we're going to be living in degrees. So you might as well just keep your calculator in degrees, and eventually you'll see a radian pop up, and you go, oh, I'll just make that one part radian, take the tangent of that radians, and then my calculator's still in degree mode. So now when I come back and I go, oh, now I need to find the sine of 30 degrees, it'll still spit out a half. So it stays in degree mode except for that one part. Does that make sense? Okay. So you're going to be in degree mode and you'll be ready to go. All right, so here's the next thing I want to show you. And this gets back to some of the work that we're doing. So if you look at, let me get out of here, I want you to go to this page 15 in the new book, book number 4. And a couple things before we get started, this is going to be important, is number 1, 2, and 3, and I only labeled this number 1 because, well, it doesn't matter. The question is, given that you have this reference angle of 75 degrees, and you remember what a reference angle is? The reference angle is the angle made by the terminal side of the x-axis. So the question is, if the reference angle is 75.3, find an angle in each quadrant that would have that reference angle. So in the first quadrant, it's saying the reference angle is 75.3. Well, what would the actual angle be in the first quadrant? 75.3, right? So in the first quadrant, it would just, and that's always true. The first quadrant is acute angle, so the reference angle is the angle. Now, what about this? What if the angle is in the second quadrant, but the reference angle is 75.3? What was the actual angle? What do you have to do that? Well, it tells you right there, right? Subtract it from 180, but that makes sense, doesn't it? You're going to take the whole 180 and subtract off the reference angle to get what's left. You're going to have to do this in this section for all kinds of angles over and over again. So let's think about it. That would give me 180 minus that, what, 104.7? So second quadrant, 104.7. Now, let's carry that over to the third quadrant. What if I have an angle in the third quadrant that has a 75.3 reference angle? What would the actual angle have been?
180 plus.
180 plus the angle, plus the reference angle. And that makes sense, doesn't it? So that gives me 255.3. And then finally, in the fourth quadrant, what would happen there? People make this mistake all the time. They go, oh, well, that's 75.3. But that's not 75.3, is it? Remember, the reference angle is always the angle that's found there. And if that's 75.3, I can just call it negative 75.3. And that's normally great. Like, honestly, if I say negative 75.3, that's fine. But you know what the book does, and a lot of tests do all the time? They ask you to solve a problem, and then they say, make all your answers between 0 and 360. And if all your answers are between 0 and 360, negative 73 is not in that domain, is it? If it's not in that domain, you can't use it. Now, you'd have to take that and add 360 to it. Well, you add 360 to that, that's what this is saying. You're just taking the 360 and adding it to a negative reference angle. Right? So what I like to do is say, all right, if it's in this quadrant, rather than just writing it as a negative angle, when it has a 75.3, I'm going to go all the way and subtract that angle, and that gets me what? Yeah, 284.7. And that's great too. Y'all with me on this? Okay, and then I'm going to let you mess with the rest of those, but let me show you why I'm going to be using this. Okay, so number 7. Number 7 asks you to find the angle. Find the angle that when you take the sine of it, you get negative 0.5983. Well, that might be easy if I asked you this. find the angle that when you take the sine of it gives you negative 1/2. If that was the case, you'd go, oh, wait a minute. I remember negative 1/2 showing up on the unit circle. And the unit circle was the y value when I was talking about sine, right? And you could go to that unit circle and say, yeah, on my unit circle, I had y values that were negative 1/2 in a couple of spots, didn't I? What were those? What were those angles?
Oh, 36.
210, 210 and what? 330. That's where I went over a lot, down a little, left a lot, down a little. And you'd say, okay, those are the two angles that are between 0 and 360. Actually, I didn't ask you that, so I'd have to do a little bit of something else. But that would be okay. But what do I do if it's not something, if it's something I don't recognize? Well, this is where that button on your calculator that says inverse sine comes into play. An inverse function, and we've kind of talked about this already, like the inverse of plus is minus. The inverse of divide is multiply. The inverse of square root is square. The inverse of exponential is logarithmic. It's what we do to get rid of something on one side. So like if I was trying to solve 2x plus 3 equals 7, I got to get rid of a plus 3. So what do? I subtract the 3 from both sides. And then after that, I got to get rid of a times 2. So what do? I divide by 2 on both sides. And if there'd been a square root in there, after I subtract 3 and divide by 2, I got to get rid of a square root, so I square it. Well, guess how I get rid of a sine? I inverse sine it. That's what I do. Now, I'm going to write this step, but I probably never write it except when I'm introducing it. What I'm technically doing is like right here, I would square both sides. Technically, you don't have to write this moving forward, but I am going to be inverse sining both sides. I'm going to inverse sine the sine of theta, and I'm going to inverse sine the negative 0.5983. And guess what happens to the inverse sine and the sine? They cancel each other, and you get theta equals. Now, right here, before you type this in your calculator, I'm going to show you something. When I inverse sine this negative value, my calculator is going to spit out one angle, okay? Not both answers. Like when we just did a problem before, we saw that when I said when the sine of theta is negative 1/2, we said that occurred in 2 spots on the unit circle. This also occurs in 2 spots on the unit circle. Your calculator cannot tell you this. It can only tell you one. And I'm really kind of jumping ahead with you, but the reason it can only tell you one is because there's this inverse sine function. It's different from the sine function, and it has a limited domain. Inverse sine can only give you answers that are acute-like, from negative 90 to positive 90. Inverse tangent's the same way. Cosine can only give you answers from 0 to 180, but it can't give you every answer on the planet. So it's going to give you one. Now, the thing that makes this a little bit more tricky that I'm going to hopefully solve for you guys or simplify for you guys is sometimes the angles are negative, sometimes they're positive. I kind of in my soul always wish they were positive. Okay? So here's what I do. What I do is instead of inverse sining that negative, I'm going to always inverse sine the positive. And in doing that, my calculator doesn't spit out an answer. It spits out a reference angle. Now, the thing that's great about that is we just did a problem that said if you know where the what the reference angle is, then you know where to place it in each quadrant, and you can figure out those angles if you know the reference angle. If I don't do this, where I make it positive no matter what, don't change the sign, just make it positive no matter what, you get the reference angle, then sometimes it doesn't spit out a reference angle. This one won't be. If you do this, it's going to spit out some like negative 40-something degrees, right? And that's not necessarily the reference angle. And on cosines and secants, it becomes even trickier. So trust me on this. I've done this for years, and the grades have been better when I do this. Okay, I got this from somebody who teaches regular algebra 2. And she goes, yeah, my kids freaked out until I told them this, and then they breathed a sigh of relief. You guys can handle, I think, once you see it, but this is going to make it easier for the class as a whole. Now, type this in your calculator, and what did it spit out?
Like negative 36 point something. Negative 36.748.
Negative 0.5983. Oh, I'm doing a different value. Okay. Let me just do this. So inverse sine, trig, inverse sine of 0.5983. And it spits out 36.74 or something. All right? Let's just call it 36.7, make our life easy. So this is not our angle, this is our reference angle. 36.7. Okay, now, our job is to find every angle that would have worked and given me this. But I know something about that angle now, or those angles. The reference angles are always 36.7. Now, here's a question for you. When do I get ratios with sine that are negative? Think about what you do with sine. Here's my unit circle. If I have an angle over here, sine is what? Y over R? Am I ever going to get negatives? No, because y is always positive. I'm going up. If I'm over, and R, by the way, R is always positive no matter what. If I'm over here, am I ever going to get sine values that are positive? I mean, that are negative? No, because y's are always positive and r's by rule are always positive. But what happens if I have an angle here or here? Your y values are now negative, aren't they? Because I'm going down. And again, if r's are always positive, you get negative over positive, negative over positive. What does that mean? Negative ratios. Do y'all see this? Now, there's a little way to know this without overthinking it. Kind of lame, whatever. If I draw this, most of you are all thinking XY axis, right? It means two things. This stands for the XY axis, which shows you the quadrants, right? But it also stands for plus. Where the trig functions have positive reference angles. Sine has positive reference angles here and here. Right? Now think cosine. Cosine doesn't deal with R. What does it deal with? Oh, and by the way, since sine and cosecant are reciprocals, that's also true. Sine and cosecant. Sine and cosecant. Cosine only deals with x's, right? So where would cosine have positive reference angles?
The right.
There and there where I move to the right. Right? It'd be net left, second and third. Those are negatives because they have negative x values. So there and there, cosine, cosine, and of course when you flip a cosine, you still use the same two letters, right? Cosine, secant. Crap, I'm running out of time. Whereas tangent, going to have,
right, only top right.
Now, tangent uses y's and x's. When would it be positive?
Oh, yeah, bottom left and top right.
Bottom left and top right, either where they're both positive, right? And I'm going to simplify this in a couple seconds. Or when they're both negative, because then the two negatives would cancel. Now here, I wrote all 6 of them down, didn't I? So what if I just said, all right, they're always, this is talking about where you would have positive, where angles would occur when you have positive reference angles. And by default, everywhere else would be negative. So the little acronym people learn for this is all S for students, T, take, C, classes. All students take classes. Okay? So if you want to know where to put your angles, or where the angles would occur, if I have a negative reference angle with sine, well, sine has positive there, so my angles must occur here. That's where they'd be negative. Because this tells you where the positive reference angles would occur. I'm sorry, positive values would occur. So what you're going to do on a problem like this, once you find your reference angle, you're going to go, all right, where would this reference angle occur? where would it occur? Sine is negative. What does that tell me? Sine is positive here and here. So where's it going to occur? There and there. So you're going to say, if this right here is 36.7 and this right here is 36.7, if that's what the reference angles are, then what are the actual real angles? And you're going to basically use that little table you had in number 1. How do you find the real angle that occurs in the second quadrant? 180 plus that. So your first angle is 216.7. And your second angle is what? 360 minus that, 323.3. And then let me ask you a question. Did the problem say just between 0 and 360, or could you go forever?
You can go forever.
So if I can go forever, what other angles occur here? What would I do? Add another 360 or subtract another 360, and I can keep doing that over and over again? So the way we write that is plus 360 degrees n, where n is known to be an integer. And this gives me all the other, anybody got the name for that? All the other angles that stand in the same place, but they look the same, but they have more spins on. Coterminal. Hey, real quickly, we got 2 minutes. Let me see if I can do this quickly. And then that's about as far as we're going to be able. We're going to be a little bit behind. Okay, right here. What would be my first step in getting rid of that tangent? Inverse tangent, but I'm not going to write it like I did before. So I'm going to do inverse tangent. It's already positive, so that's good. But I'm going to say, all right, it's positive, so I don't have to change it. But I'm looking for the reference angle. And we type it in our calculator, and what do we get? What do you got? 74.1? Sorry, my ears. Now, what does this stand for again? A reference angle. This is tangent. Was the ratio positive or negative on this original problem? Positive. Based on all students take classes, where is tangent positive? Third, I'm going to have one angle there, and where else? First, because they're all positive there. So, those are the reference angles, but I don't want the reference angle. What do I want? The actual angle. So what's the first and the second actual angle? Well, the first is 74.1. And then lastly, what's the second? 180 plus 254.1. And what do you not forget? Plus 360 degrees n. And guys, we're going to have to talk about what to do when it's cotangent, secant, cosecant, when you don't have an inspire. If you have an inspire, you just keep going as usual. Sorry, ran a little late. We'll get it all right tomorrow.
Is there another video on? Another video tomorrow posted.
Sure.
All right, I'm good. Thank you.
Yeah, ma'am.
All right, and I'm still taking my test 4th period tomorrow. Right?
Oh, yeah. Yeah, that's the plan.
Okay.